Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with our series on Engineering Sciences Fluid Mechanics questions. This has been referred by Pankuri. She has asked me, sir, please solve 2015 XEB Fluid Dynamics questions. Okay. So now one of the things I could do is two things. One is individually I can solve. Second one is all the things together in one paper, one video I can solve. I chose the first one where I will solve individual problems, each individual problems in one video. Now this, what happens when a person is studying one particular topic, he will get to know the similar questions that has appeared in almost all the papers in GATE. Okay, so that is my intention. So I hope you understand, students. So let us go for the question. So the question is like this: a rectangular boat 6 meter wide and 15 meter long, okay, dimension perpendicular to the plane of the figure, that is 15 meter is dimension perpendicular to this, okay, has a draught of 2 meter. 2 meter means it is below the surface for 2 meter. The side view of the boat is as shown in the figure. The center of gravity G of the boat is at the free surface level. The metacentric height of the boat in meter is. Now first we have to understand what is metacentric height. How do we get it? What is the formula for that? Okay, so the formula for metacentric height is given as Gm, that is center of gravity to the metacentric height, metacentric point. Gm is equal to Iyy divided by volume minus Bg. Let me tell you, my reference book is SK Som and Biswas. Okay, so if you have any trouble, you can refer to that book. Okay, so Iyy, when I say what is the yy axis about which I have to take the moment. Okay, so the moment of inertia you are taking along this axis, that has to be understood. Why? What is moment or momentum? What is moment of inertia? Moment of inertia is the axis about which it rotates, and also yes, it is the axis about which it rotates. Okay, for example, here when it is overturning, metacentric height is related to overturning of the ship. Okay, so this particular boat, if it overturns in this direction is called roll. Okay, so if it is rolling like that, there is a possibility of overturning. Here it is important that we be careful about the metacentric height. Okay, so now to do this we have to take around this axis. Okay, so that axis, if I take the Iyy, this is y and y. Okay, so Iyy here is if you say BD cube by 12, what is D here, what is B here? This would be B, this would be D. How do you determine that? For example, in case of if you say columns, for example, okay, if this is a column, okay, I'm sorry, if there is a column like this, okay, so in this column, if there is a say bending which is there because of the load which is put, if there is a bending, what is the cross section we take the moment of inertia with respect to? We take with respect to this, right? In columns in solid mechanics you might have seen that. But now what is that axis about which you take the moment of inertia? You take the moment of inertia about this axis, correct? So about this axis, when you take the moment of inertia, this is D, correct, and this is B. Similar way, here you get that what is along the axis is B, along the axis is B, perpendicular to the axis is D. So perpendicular to this axis is 6 meter and B is the 15 meter length which we take, correct? So this 15 meter length we take along the perpendicular. So this would be 15 into 6 cube by 12. Major catch is here only. Major catch is to find out the moment of inertia. Once we find out the moment of inertia, everything is done. Okay. So this particular thinking you have to understand. Okay. So 15 into 6 cube divided by 12. Okay. Now here one more point. How does this rotate, sir? Stagnant. No, it is after it has bent, you see it comes like this, you see. After you see it has bent, if it is on this side, it will go like that. If it is on the other way around, it will go like this, is it not? It will bend. Which axis it is bending? The cross section is bending along this. Like that we can understand. Okay. So this answer I get is at 270. And this is first catch. Second catch I will tell you. So this I will put it as 270. The second catch is volume. Volume is the immersed volume. What is the immersed volume here? It is 2 meters into 6 meters into 15 meters minus Bg. What is Bg? Center of buoyancy to the center of gravity. Center of gravity is here. What is the center of buoyancy? Center of buoyancy is the center of gravity of the displaced liquid. What is the displaced liquid? Whatever is below the surface. And that distance here, Bg, would be 1 meter. By common sense, we can get that, right? So this is B. This is center of buoyancy. Center of buoyancy is at the center of the immersed liquid, right? Or immersed, whatever the volume is immersed, the center of gravity of the immersed volume gives you the center of buoyancy. So Bg is 1 meter. And when you do this, you will get 1.5 minus 1, that is equal to 0.5. So the answer is 0.5. B is the right answer. Thank you very much, students. Next question will come in the coming video. Okay. So thank you very much. Any suggestion you can put it on the comment section, and my Facebook page I have shared. In that my contact number is there. If you want, you can WhatsApp me whatever questions you want to ask. Thank you very much.